Thanks. Hello, everyone. I hope you're all doing well and you're enjoying the conference. Happy to be here on stage. And what I want to tell you about is how you can leverage also the serverless patterns for your front-end applications and what that will give you. But before we jump right into the topic, a few words about me. As already said, hi, I'm Florian. I'm a solution architect from Munich, Germany, working for a smaller company called SmartPiot. We are mostly doing consulting in the architectural space. So I'm specialized in distributed web applications, but in general, that's also why we have IoT in the name. We are also conducting architecture on huge IoT platforms and projects in general in the digital transformation space. I'm also an open source enthusiast, and what does that mean? I'm a Microsoft MVP in the area of development tools. I think already for now 11 years or so. Let's I stopped counting, but somewhere there's the official number. I'm doing mostly projects in the .NET and JavaScript, TypeScript space, and I'm also writing for various blogs and magazines. I've written a book on the subject called The Art of Microfrontends, and there will be a second edition of this book out mid of this year. So currently working on it, and I think it will be quite a good update. But enough about me and enough about the work I'm doing. Let's just jump right into the topic. And I want to start with a little bit of a reminder. What's the difference between microservices and serverless? So just backend side, and that will help us to identify what now serverless for front end means and what the benefits there are. So if we look at microservices, I mean, you're mostly thinking maybe of, I don't know, Kubernetes deployed clusters or Netflix maybe when they started, let's say, making a huge buzz around that topic. And what you also might associate with it is that you want to ship, for instance, your artifacts in form of a Docker image or something like that. And when you think about that, you always know that what must be in there is no information regarding, for instance, operating system and all these things, but you need some kind of a runtime. How deep that stack is and what that all involves is, I mean, up to your implementation. But you need some kind of a runtime. So for instance, if you ship microservices in ASP.NET Core, you want to have the whole ASP.NET Core runtime for each microservice attached, right? And of course, you need to deploy that somewhere. So you need to have something available somewhere. And that, of course, could be some managed service as well, like, for instance, Azure App Service. But nevertheless, you need to have some space allocated somewhere. And you need to have a deployment pipeline tailored for this thing, right? And then in the end, of course, when you deployed your microservices, you need to have a way that they can talk to each other, right? So either via direct calling or via some kind of a service bus or a queuing system, etc. So if you make that directly, indirectly, etc., it's up to you, but you need to be in the chair here and make a decision how the orchestration is done. So in contrast, if you look at serverless patterns, take, for instance, Azure Functions just as an example, you will see that there is no runtime that you need to deploy, right? The runtime is already set by the platform for you, which has, of course, pros and cons, you could always argue. But what we are after, of course, it only has the pros because we say, oh, yeah, anyway, the runtime is settled. We don't want to care about that. It should be already there. And there, of course, are certain advantages from the perspective of the provider you're publishing to, because it doesn't need to spin up a lot of different full computing instances, but potentially just a few, and they can handle lots and lots of different such functions, right? All right, then continuing from there, I already mentioned that. So this is now a platform, some kind of a provider. So you don't need to let's say, care about now what server or which infrastructure is this directly published. You just say, provider, take my input, I don't know, take this tarball, it contains a valid Azure function, for instance, and then do the rest, expand it, bring it in your infrastructure, do whatever is necessary to make that available. So instead of now needing to care where to deploy exactly, just publish to the provider, there's just this one option and you're good, essentially. And finally, most of these serverless providers, they give you already some kind of auto orchestration. So for instance, Azure Functions is really deeply nested in the Azure infrastructure and allows you to use already a lot of services out of the box that are there that you potentially already allocated, and the wiring up is just done automatically for you, which is quite great because there's one thing less to care about, right? Still, of course, in a runtime like Azure Functions, you can still add, of course, custom things that you want to integrate and environment variables and whatsoever. But generally, the orchestration is done automatically, and you can see that on a couple of points. So in short, what does that pattern give us in comparison to microfrontends? Well, serverless reduces the scope of the service that we want to write to focus exclusively on the domain functionality. So it tries to get out all the technicalities that might be there, right? So how do you deploy that? What's the mechanism behind that? How do you orchestrate that, etc.? Just push out, it's not your problem anymore, and you can solely or almost exclusively focus now on the actual problem you try to solve, right? And that's good because quite often we are not paid to reinvent the wheel, but we are actually paid to bring in some new feature to whatever kind of product we are working on. And this is exactly the aim that serverless tries to give us. Now, where does the front end come into play? Well, looking generally at the evolution of the web as a platform and the web as something that, our products live on. We all started in the mid of the 90s with the monoliths, and monoliths, of course, are still present today, and there is nothing wrong with a monolith. I always say if you have a good monolith and that solves your problem and you don't have any other issues, stick with it, because there's nothing simpler than that. And the monolith I'm talking here about is, I mean, the classic onion architecture, right? You have your database access, and then you have a rendering layer, which receives, of course, user requests, renders some HTML, gives it back. So front and back end all in one box, essentially. There is, of course, somewhere a database usually involved, but it's this classic monolith we are talking about. And that whole changed, of course, with the advent of start of the 2000s, around 2004-ish, with the arrival of stronger web apps like Google Mail, for instance, or Google Maps. And suddenly there was a little bit of a more drive towards also being able to update parts of the front end dynamically. And there was a rise now of the APIs on the backend, so not only just for generating HTML, but actually just giving back some parts of data, right? And you could think about it as kind of a direct database access, but of course, usually there's a little bit of business logic on top of it, at least checking, for instance, API keys and whatnot, right? Anyway, so this allowed now that applications like, for instance, Google Mail didn't need to re-render the whole screen. They just, you click on the email, now we go to a dedicated backend API, we only fetch the data for this one email, and we only update the fraction of the screen that is responsible for rendering this email, right? And this made, of course, Google Mail a rather fantastic experience, especially in contrast to all the other web mail providers at the time. And of course, this pattern was so successful that what we know today as a single page application stands really on top of that. It's just this thing driven to the extreme, where the whole application is then just the JavaScript, because you don't want to have the duplicates in the rendering logic, right? You don't want to have the backend and still care about that, and have it also in the front end, and both things do something and they share, of course, or have a huge overlap there. You don't want that. And that is, of course, this one extreme side. Now, things scaled more and more, and what essentially was in the beginning just a little helper that we now have this backend API suddenly became actually a crucial thing, because with the advent of mobile or native mobile apps, suddenly these APIs became rather crucial, right? Because now you had different clients. You didn't only have a website, you might also have a native application, and both things required the same data, or let's say kind of the same data. There might be something that the web app also needs in addition, and the same might be true for the native app. But nevertheless, there's a huge chunk of data that's definitely shared, and you want to have that in your infrastructure somewhat. Now, what I just said in the beginning, what Netflix did is they thought about all the patterns that were there, including SOAP, and they said, well, let's a lot of guidance, a lot of restrictions, and actually it should be all about an organizational pattern. So we leave free how you do it, just what you need to do. You need to decompose, you need to make smaller services, not necessarily smaller in size of, I don't know, lines of code, but smaller in size of, in terms of what domain functionality is covered from the service. And we call them microservices. And ideally, I mean, they are also loosely coupled and they communicate depending, of course, on their needs in an asynchronous manner and all of that. But nevertheless, what we usually find out is we can now have multiple teams working on one backend solution. And it mostly looks like this. You have a common, well, let's say, entry level, let's call it a gateway. But it could be also named differently, backend for frontend, etc. A couple of names out there, slightly doing different things, but it's always an entry-level service for your backend. And then you have your different domain services in there. There might be also different levels, auxiliary services, main services, and whatever. But yeah, in general, it looks like this. And that, of course, was great because it didn't have many restrictions, and that is one of the problems of microservices. They don't tell you how to implement it, just how it should look like or how it might look like in the end. But then again, it allows the teams, if set up correctly, to scale really well in development on the backend side. So this is great, right? But now the problem, and that has increased the last, let's say, decade up to this point, and in 2017 a new pattern was therefore found, is what to do with the web front end or with the front end in general. This is still monolithic, and that has become a bottleneck, right? Because with every change that might happen in the back end, it might spawn a change also in the front end. If it doesn't, it still might require an alignment, right? And there will be lots of requests from the backend team to the front end team. Hey, we now added this. Can you change that? Can you do this and that? So a lot of requests going on, and the front end is not a bottleneck with this. It can't scale because, as you can see in this graphic, it's still one team, maybe a large team, but still one team. So what the people thought up in 2017 is to come up with a new pattern, and they called it micro frontends. And the name was chosen, of course, wisely or not, you can decide that. But it was chosen because it is also an organizational pattern. So like microservices, it doesn't tell you anything about how to achieve this, just what you want to achieve. Now this, of course, again, has the two sides. So one is you're quite free in how to implement it, but second is you don't know where to start from, and you need some experience to actually come up with a good solution. But nevertheless, how it might look like in the end is a really nice symmetry to the microservices. Instead of having now your gateway, you have an app shell. An app shell, sometimes people phrase it differently, etc. Sometimes they have a little bit of a different understanding, but essentially this is always the HTML page that serves it, or the server that gets the request if you have a server-side pattern. So it doesn't necessarily mean that you always just have an empty shell and there is nothing in there. But yeah, it's just this entry level, and there could be lots of things in there actually, and that's just how it goes. It's just the first thing that the request or that receives the request. Now behind that, of course, there are now multiple teams working on independent functionalities. So subdomains of your application, if you want to call it like that, and they all write fragments. So there could be page contents, simple UI elements, I don't know, a menu item that should be displayed somewhere, could be up to full display elements like a footer or header, even though I always advise against such large pieces. But nevertheless, that how you split now your domain is up to you, and these could all be things that are crafted in different teams here. All right, so these are micro frontends. What did I just tell you? Well, here's another graphic taken from a book of Michael Gers. He has also written the first book on the topic, and I think it's a great book, so I can also recommend this one. And essentially what I just told you is also summarized here. Let's say you have 3 independent teams, A, B, C. So what are their jobs? Well, they compose different parts of the UI. So as you can see in the graphic, team A produces this fragment A. and team B produces some kind of a page. There might be already some content in there, but it now decides that, oh, we have this thing, let's say it's recommendations or so, and this is a piece that's written by team A, so we can introduce it here, right? And likewise, the same with artifacts now coming from team C. So these are, you could say, parts of a library if you want to, but the difference to a library is that these are usually not combined together at compile time, but at runtime. So it's not just some library you use and say, now I use this component. No, it's actually more like a placeholder, and at runtime it's decided what flows in there. Which allows you, of course, to update these things. And again, that's like microservices, because they're also, if you communicate to another service, you do that via HTTP at runtime, right? You get the information, not via, I consume a library, and that's it, where everything will be combined together, and an update would imply also updating the current service. And here the same. In order for fragment A to be updated, you don't need to redeploy the page of team B here, right? So this is quite important. They are runtime integrated. Now there might be some shared topics here, like performance, for instance, or a common design system. But nevertheless, in general, the teams are quite independent, and they are always cross-functional, meaning they have always a business guy in there, someone for the front end and potentially for the back end, depending, of course, how the solution is crafted, etc. But that also, of course, would allow you to create real full-stack teams using this pattern, because now you cannot only make an independent backend service, but also an independent front-end fragment, right? All right, and this is also, of course, illustrated in this graphic from Michael Gare. So you started on the left-hand side with, let's say, microservices. You have already a content service, attribute service, payment service in this graphic. And the bottleneck here is, of course, that the different teams, like these three backend teams, they will have communication patterns that will always reach out to the same area. So front-end, business, operations. And you have these islands that are bombarded by requests. And by, let's say, shuffling it a bit and going to micro frontends, you achieve this full independence that's then shown on the right-hand side here, where a member of each team, you see a member of operations if needed. You see, for instance, the team Inspire is mostly crafted of the content service beforehand, but they also now have a front-end person in there as well, etc., etc. So this is now all, I don't want to call it full stack, but really cross-functional, and everything that's in there that's needed to have an independent or a subdomain covered is in there. So full independence achieved. So to summarize, it's all about the distribution of work, like with microservices, and the basic idea is that 3 8-person teams are more effective than one large 24-person team. That, of course, only holds true if they are independent. If you need a lot of alignment between these 3 teams, it doesn't work. So who uses microfrontends today? This is just an excerpt, and to be honest, quite an old one. I don't know when I crafted this graphic first, but I think it's like 2 years maybe already old. And even back then, I mean, there were a lot more companies, but just to illustrate that it's used across the board, because in there you see e-commerce or commerce companies like IKEA, for instance, it's the web shop, right, or Zalando. But also, of course, then applications like PayPal, for instance, or Deutsche Bank is also using microfrontends for the banking applications, so also there. Things like the Zone or Spotify, of course. So these are also more application-like websites, but nevertheless, so this is where microfrontends really can make a lot of sense. But it's really used across the board, and they're not, of course, all using the same pattern. Some of them are more server-side driven, some of them are more client-side or in the browser composed, but nevertheless, they are all working on microfrontend solutions for their space. And potentially you've also used microfrontends, even though you didn't craft a microfrontend solution, because very often, for instance, the advertisements that are running in an iframe, they qualify as a microfrontend. So this is a completely independent thing. A team that you don't know potentially, they crafted something, they have this fragment, and you include it via an iframe. Well, it's a microfrontend that you're using. Doesn't mean you are now having a microfrontend solution, just means you already used microfrontends maybe without even knowing. Another example would be chatbots, for instance. So there are a couple of these third-party services. You include them, and suddenly they bring up a pop-up or something on your page. Well, they also introduced a micro frontend because, again, they're working independently on that. They can make updates, and all you had to do was include a script tag or have an iframe directly in there, something like this. And yeah, this is a micro frontend. Now, we wanted to go serverless for microphone. So 20 minutes in and you're thinking, oh, what is this guy telling me? Well, this is all important because in order to know the difference to now serverless for frontends to, well, having still to operate something, you need to understand first what microfrontends are. Now here we are, a classic microfrontend usually is also composed like a microservice of a runtime. You need also a place to deploy it somewhere, and you require an orchestration to have these different fragments then talking to each other, or at least, you know, forming an ensemble of things that look nicely and coherent to each other, right? So these are the three components that we've also seen with microservices, right? The runtime may now something be that, I don't know, you use a tool like Webpack Module Federation, which is quite a popular choice. This brings in this runtime from Webpack and has this orchestration layer also from within this runtime. The deployment, well, if you go for browser composed microphones, it's just static storage, but you need to allocate static storage somewhere. If it's backend driven microservice, you still need a server, so you're in the same area as with the microservices there, etc., etc. So these problems that we've seen beforehand, or let's not call it problems, maybe just properties, they are also here. And you might guess it if you now go to serverless, which I call not a serverless function because these are not functions, right? So, but Siteless UI, so if a website that doesn't have a real need for a website underneath, but it's still giving you an UI, they don't need that, right? So what we will see is that you can deploy something again to some provider. We call it a feed service, but yeah, you could call it something else. You could have something else here as well. And this thing now defines your runtime essentially, just like an Azure function does. So you don't need that. You really just deploy the raw thing for Azure function. If you think about it, it's just if you use C#, your DLL with your raw definitions of the endpoints in there, right? And the manifest, it's the same here. So you would also just need your code that's then being run from the platform, and you would need a manifest, of course, to tell the platform which parts of the code to run in under what circumstances, right? And again, the orchestration should be automatic. Now, I already took away that, but just to summarize, what's now the thing that Siteless UI, so which is essentially serverless for not backend functions, but UI fragments, and serverless functions have in common? Well, both should allow you to develop the code in some standard IDE. Use Visual Studio Code, whatever. There shouldn't be a requirement to do it, I don't know, in an online editor, so or a special kind of application that exists somewhere. So just a standard IDE and you're good. Now, if you want to run that locally, of course, you don't have a runtime, which means you can't just start it, right? You can't just start an Azure function unless, of course, you have the right tooling around it. So the Azure function tools, for instance, because they come with a so-called emulator, and we have the same here. So you want to have an emulator that reflects what the runtime, etc., would give you. Now, what this gives you out of the box is loose coupling. You can, of course, strongly couple as much as you want, but such a platform, what should it give you? It should give you a way to actually loosely couple your resources, in this case, loosely couple access to other fragments that will make you scalable, which is great. And as already said, you need to provide some self-definition or kind of a manifest to tell the platform now what your code is actually about, right? How is it called? So now, finally, as already mentioned, deploy without a runtime. And what you get by applying this is also the same as the serverless, instant availability, right? So you just deploy it. Once the upload process is finished, this thing is there and available for everyone. And that would be the main selling point, of course, rapid development of features as you want it. From a development lifecycle, you get the same benefit as with micro frontends, maybe a little bit better because you don't need this orchestration layer and the maintenance layer on top of, I don't know, some resources. So you start with your app shell. This will form the basis of an emulator, right? And once you have a first version of this, you can start then development of your individual Siteless UI modules, right? So, for instance, a first team would start development of module A, and then they would iterate on it, and they would deploy whenever they feel like it's a good next step, right? Which could be for this team at the end of each sprint. That's now fully left to the team. And then we also might have another, let's say, set of teams. Let's call them team for module B and team for module C. And they also then onboard on the platform. They just push also their fragments on it. And what you can see is that their release cycles are completely independent of each other. So a module B team might feel like, oh, we have some new feature to have for our users, so let's just deploy right now. They don't feel like sticking to, I don't know, end of the sprint or something like that. And that's important because every team now can have their own cycle that they are, let's say, feel relevant for whatever kind of domain they have, plus, of course, they feel comfortable with. So this is good. Each team has different needs, and they should be able to just find the best solution that works for them and not work for others. Another side effect that allows this thing for you to do is that you can actually now stage individual parts of your system, right? So what I mean by that is, let's say your front end consists of a lot of different fragments, and what you can now do is just an individual part of it. You can say, I roll this one back or I bring it to the next version, independent of all the other stuff. So whenever you feel that you have something out there that doesn't really fit together, you don't deploy it. So what you can see in this graphic here is, for an older project, what we did is, you see the overview of the special front-end feature, which was an API key management module. Doesn't really matter, but you see there were 4 environments used, and with out-of-the-box methods, like here Azure DevOps was used. You can have a nice dashboard of looking at what feature is available in what environment. So if you define that or have it integrated via your CI/CD pipeline that it pushes to the provider, etc., you can have this thing like out of the box, right? There's nothing you need to do on technical side in addition to it. This just then works with whatever you have beforehand. And usually that's a nice symmetry again to what you're doing on the backend, because there you might have a similar view already. Now, what's then behind it might be different, right? And in one case you deploy a Docker container, and here you deploy, an npm package. But end story is the same. You get the staging, and you can just do the same thing, right? So how does it work then? Let's say more on the technical side. This is just an example using a framework that makes this possible, but you can also create it from scratch. The framework is called Pyral, and micro frontends or modules for Siteless UIs in this case are called pilots using this framework. So what you would do in this kind of framework is that a developer of such a module uses the tooling and is able then to bring it now to not a Lambda, but a Pi, right? So Lambda is for the serverless functions, Pi is now for the Siteless UIs. So this is the platform where you now want to bring your micro frontends in. And what the end users will see is, of course, also delivered by this platform. So this platform delivers you the whole application as you defined it, which is called here Pyral instance, and all these modules that have been developed, all these pilots, right? So they're all delivered now from the platform. So everything you need to get started is already there. So how does this now look in practice? In an example, let's have a look at a Netflix demo, because everyone knows Netflix, and I mentioned at the beginning already. And now, not of course from a microservice perspective, but on the front end. So this is a reconstruction of a Netflix application. And what the video will show you here is This recreation has different profiles, so we're now using Jane, and you see there are these favorites, which is like a watch list, right? So you can also go to the page containing all your favorites, and if the job would be to create a new feature for this application, you could just scaffold a project in the command line. Sorry for jumping over it so fast, but yeah. Now the team is writing a little bit of code. What it does exactly doesn't really matter now. They're using React, but yeah, could also use something else. But the important piece, and we will look at that also in a second with a little bit more time, is that they write this setup function, which is like the self-definition or manifest, because that's called from the platform, and it then wires up all the different fragments to where we want to see it in the application. Now we can run that locally, and as you can see, we already see our Netflix logo, but everything else is blank. So this is because, well, I mean, we are just isolated here, right? We don't have all the other fragments. But there's some browser extension, there's a tooling, and you could bring in all the other micro frontends, what we can see here, and suddenly, voila, this thing expanded. And it's now looking more to the application that we've seen beforehand, except we have this surprise me button in the top. And this is the new functionality that was added by the one team, right? So they now say, hey, cool, this is working. However, as you can see, it's not live on the full, on the internet view, on the production website. So what do they need to do? They can log in into this platform, and they could just package up their thing, build it, package it. It's just a tarball. So what they can now do with this tarball, as you can see it here already, there's the TGZ, right? They can just upload it here. And of course, you could do that via an API, so from your CI/CD as well. But yeah, we do it here in the platform directly. And once you're there, well, you got it already on the production view, right? So your production website was just enhanced with this surprise me button containing the view that we've seen. So quite cool. And how does it work? Well, the whole example here is composed already, as you might have seen, from a lot of different micro frontends. So we have, for instance, a micro frontend dealing about the browse page. Now, these are micro frontends, as I say, but we are more closely, of course, to this Siteless UI module. So a micro frontend with, let's say, no runtime, nothing in there, just stripped down to raw functionality and upload to the platform. Now we got more modules here, like for instance, we've seen favorites. It consisted of a menu item. It also had a page, and it also had another component like the little heart or the larger button on the teaser, right? There are more micro frontends. Search is here mentioned, right? And we also have a micro frontend regarding profiles. They always come with different components. And again, this Siteless UI platform, it orchestrates all these things for us, and there's nothing we need to do about it. Importantly, already the preview of a movie, that's already a component coming from one of these modules, right? And if you don't have this module loaded, what was the case when we started local debugging? Well, if we use it, we don't see it, but the application doesn't crash. That's an important part of this loose coupling. I mean, it's there, you can use it, but if it's not there, nothing bad will happen. You could actually also define what is a fallback and things like that, but yeah, you could also just leave it free. So now let's look a little bit more deeply in the remaining minutes on how this now looks in practice from a technical point of view. Let me open VS Code here for you, and let's inspect what we've seen just as a glimpse of it beforehand a little closer. This is the index TSX of such a module. So it will remind you very closely on how you write, for instance, an Azure function using JavaScript if you've ever done that. Except, of course, that your manifest is now not a JSON, but it's a functional file. It's part of your code base here. And there are various reasons for having this. I mean, you could, of course, think about or create such a platform with a JSON, and that's perfectly fine. What a code file gives us as an advantage is that we could already, let's say, introduce also abstractions. For instance, if we want to say, we want to use here a component called favorites, which we of course lazily load. So this is the page with the favorites. we could already inject another component that's just loosely coupled in there. And this way the actual favorites page doesn't need to care about how it needs to load it, etc. Right? So this is quite good. Also very simple components. They can also just be written here in code, and there doesn't need to be an extra file for this, which is better for the performance of the system. But I mean, these are subtle things. In any case, what we do here is register so-called menu item, which is the favorites menu item, register a page, which is the /favorites, and register a so-called extension, which is just a very generic component, and we register it by the name list toggle. And this list toggle is used on a couple of occasions. Actually, if we look here, and I have all the different modules already in this directory, so that it's not so difficult to navigate the code space. You will see that, for instance, we have it on the browse page. It knows that there might be something like a favorites button. The naming here is not really good because, well, actually there could be anything behind it. But here it already from the naming assumes it's a favorites button. But yeah, make no mistake. Usually you choose better names, right? In any case, it supplies this one already to the browse page using the same pattern we've seen beforehand. And this way, I mean, the favorites are placed in there with this heart icon. We also see it on the watch being used, right? So it also has this toggle that it supplies to a so-called movie tile. And again, that's another extension that's registered, and the movie tile is then the most important thing. Let's see if I can find it. I only see it in the register extension, but I'm not sure if I here browse. Yeah, so anyway, it takes this movie tile in this showcase and wires it up together. Now, what is the end result of that? The end result is that we are loosely coupled, right? So we are telling the system here, we have something, we have a page, we have whatever, and here it is the code for that. Now, no one else, no other module needs to tell the system about it. Other modules just tell, if you have it, I want to use it, right? So, which means if it's not there, there's nothing going wrong with it. Looking at this example, let me just show you this in a demo. So here's the page we've seen beforehand, right? Just now running online, and you see this add to favorites, so I can refresh, and here it is. What I could do is I could just disable it, meaning it will not be served now. And if I now refresh, it's gone. And it's gone consistently, right? So here's no button anymore. Here we don't have the page, and we don't have these icons. Just as a comparison, let me turn it back on again, and it's available again, right? So we enabled this one feature. There's nothing in our code that says if feature is enabled or disabled, because our code is completely independent of that. It's already loosely coupled, right? So the platform handles that for us, which is quite great. And the only thing we need to care about is that it always looks good. But this doesn't have, let's say, an implication on, you know, that you already look ahead that there will be a favorite button, but just that when you introduce something, some slot where it could be extended, like the header bar, or here we said, oh, there could be something that you think about, well, if there is something here that was obviously not solved very well, that, yes, it always looks good, right? So there is no collision in the styling, etc. Anyway, surely this turning it on and off for everyone is quite a massive measure, but you could of course think about more. So one example that you could do, and then I will stop with these examples here, but just for food for thought, is you could introduce rules. So what you could, for instance, say is, and don't do that in practice, I mean, maybe that might be a good reason, but it's, I think personally, really good for demos, is to introduce a browser filter and maybe say only available in Firefox, right? So we just say allowed browsers Firefox, we save that, and here it is. It should still run because we're in Firefox, but let me show you the same thing in Chrome. it's not there anymore, right? So there's no favorites here, and it's gone. So they now look different. And I didn't do anything in code, right? I'm not in my code now branching out. And again, the decision when to do that is up to me. So I could just remove this one thing and refresh, and now they got it back again. So it could be something completely different for the decision when to display it. And it could also be, of course, tied to user permissions. You only want to showcase, I don't know, certain actions if the user has the rights to execute them. Because otherwise, I mean, you would need in your code to hide them, etc. And that's not very good. Of course, your backend still has the power to then allow or disallow, but that should be synced with the front end. And this is a very easy way to do that you have essentially like some authentication that you actually synchronize with your front end, and you use these rules and you use the platform for this, right? So that is, in my opinion, very, very efficient to do that. Alrighty. Looking also at the time, I think if there are questions, of course, we can go into more detail on the code. Yeah, more or less, this is if you ever dealt with a React code base, this is just React. But it could also be that we, instead of having React components, it could be Angular or Vue or whatever, right? It doesn't really matter. It's not the real crucial point here. Just the point that you have different things coming together, defined by the serverless or siteless UI platform. All right, so let me go back to the presentation and round that up. I hope you enjoyed the session. If you have some questions, I don't know if you can place that in this round. Otherwise, also ping me, connect to me on LinkedIn. And I wish you now a great day. Enjoy the time and enjoy the rest of the conference.
Thank you, Florian. Thanks for your session. Thanks a lot for giving a bit of a context there for all the applications and the services there. Thank you.
Thank you. Have a great day. And
Likewise.
as said, connect to me if you have any questions, and wish you all a pleasant conference.